Welcome to Cows and Climate. My name is Frank Mitloehner and I'm a professor and air quality specialist in the Department of Animal Science at UC Davis. If you as a farmer or you as a region or a state don't add additional livestock to your farm or your locality, then that means that you're not adding additional methane to the atmosphere. If you're not adding additional methane to the atmosphere, then you're not adding additional global warming. And this is a point that's very critical. What I just said about methane from livestock does not mean at all that we must neglect it as a greenhouse gas. Methane is an important greenhouse gas. But if we don't increase livestock herds, we are not increasing that gas, meaning we are not contributing to additional warming. But if we manage to improve performance of livestock, let's say, and thus reduce animal herds and use more with fewer animals, like we have been for decades, then that means that we are reducing the warming impact. And in fact, we are inducing something called global cooling. I know that's a strange concept to many, but if we are taking methane out of the atmosphere, then that has a cooling impact, which counteracts some of the other fossil fuel related heating impacts. So we are reducing methane as we speak. The dairy industry is showing remarkable reductions in methane, and they have pledged further goals, reduction goals that is. In California, we have the overarching goal to reduce short-lived climate pollutants, and what they mean is methane, by 40%, 40, by the year 2030, below 2013 baseline. And that is a massive goal. If that goal were to be reached, we would have a profound success story, one that helps us to reach societal goals of overall lowering of our carbon footprint of society. In order to achieve that goal, state agencies, scientists, and the industry are working together collaboratively in sharing information on what baseline emissions look like, what kind of mitigation technologies there could be, and what kind of incentive funding there might be in order to assist farmers in implementing those technologies. These technologies include things such as anaerobic digesters, which are basically a way of capping the animal manure on a farm and trapping the resulting gases. You can take that gas, much of which is methane, and then you can make use of it by either producing power or, and that's more what we do here in California, converting that methane into usable gas, which becomes fuel. And by doing so, we can take that gas, that fuel gas, and replace traditional fuels such as diesel with it. And that has a double whammy effect. These so-called renewable natural gases can be used to replace diesel in a traditional vehicle fleet. And that has a great impact on lowering overall emissions. So renewable natural gas is actually a carbon negative fuel. And that means, in other words, between us capturing the gas, now it's not going into the air, it's captured, and the use of it, it actually reduces the amount of greenhouse gases in the atmosphere. So in this way, a dairy farm does not only help shrink its own carbon footprint, but it helps to offset overall carbon emissions of society, let's say from transportation modes. In addition to anaerobic digester technologies, the state also incentivizes the use of what's called alternative manure management practices. And those are non-digester practices, such as using certain kind of separation technologies, separating the liquid from the solid fraction of manure, and other technologies that have also been shown to markedly reduce greenhouse gases. So what about enteric emissions? The world talks about cow belches. Some erroneously talk about cow farts, but believe me, it's the belches. So how significant are enteric emissions? They are significant. In California and throughout the country, they might be of equal importance as greenhouse gases coming from manure. But the good thing is that through research, we are finding ways of reducing even those enteric emissions. There are certain feed additives that you can feed to a cow that can help to reduce the enteric methane that stems from their digestive processes. So there are all different kinds of technologies. Most are in research stages, but we have found approaches that might lead to 20, 30, maybe even 40% reductions of enteric methane. And that makes us very hopeful.